Here's a line that looks harmless. Check whether 10 divided by x is bigger than 1, but x is 0. And dividing by 0 is the one thing math absolutely refuses to do. Watch it blow up. 0 division error. The program crashes hard. Now, what if I told you Python has a built-in way to skip that division entirely without a single if statement? It comes from a habit Python has of being lazy. It's called short-circuiting, and it's quietly one of your best tools. Python reads and/or expressions left to right. With and, everything must be true. So the instant Python sees a false, it knows the whole thing is false and stops, without checking the rest. With or one true is enough. So the instant it sees a true, it stops. It never evaluates what it doesn't need to. That's short-circuiting, don't take my word for it. Let's prove it. On the right of this, and is 10 divided by 0, guaranteed to crash if Python runs it, but the left side is already false. With and, that settles it. So does Python even touch the division? False. No crash. Python saw the false on the left, knew the and could only be false, and never evaluated the 10 over 0 at all. The dangerous half was skipped completely. Or short circuits on the first true. Same booby-trapped division on the right, but now the left is true, and with or one true is all it takes. Predict it, crash or no crash, true and no crash. Once or found it's true, it stopped and ignored the rest. This isn't a quirk. It's a promise you can build on. Now let's use it to save our crashing program. Put a cheap safe check first. Is x not 0? If x is 0, that's false, and short-circuiting stops right there. The division on the right never runs. The safe check guards the dangerous one. False, calm and correct, no crash. Same x equals 0 that exploded a minute ago. The only change was putting a guard in front and letting Python's laziness do the rest. Here's the catch. The guard must come first. Same two checks, but flipped. Now the division sits on the left, so Python evaluates it before it ever reaches the x not 0 guard. Watch what that costs us. Crash again. The guard was useless behind the danger. The rule is simple. Always put the cheap safe condition first and the risky one second. Short-circuiting only protects what comes after it. The same shape guards against none. Only compare the value if it actually exists. Value is none here, so the left side is false, and Python never runs the greater than check on a none. No error, just a clean false. False. You'll write this pattern constantly. Check something exists and only then use it. Short-circuiting is what makes that one-liner safe. Chain several and the logic flows in order. Old enough and enough money to cover the price. Python checks the age first, true. Then the balance. 50 covers 40, so both hold, true. And if the age had failed, Python wouldn't have bothered checking the balance at all. It reads left to right and quits early. Every time. Real quick, if this is clicking for you, tap that like button. It genuinely helps other beginners find the series. And hit subscribe so the next episode lands right in your feed. Short-circuiting isn't just an and thing. Read it as either count is 0 or the division works out. Count I is 0 so the left is true, and or stops right there. The division never runs even though count is 0. True, no crash. With or, you lead with the case that would make the risky part pointless. Same protection, mirror image of the and version. Guards chain as long as you like. Old enough, has an ID, and not banned. Python checks them left to right, and the first false would stop the lot. All three pass here. True. Put the check most likely to fail first, and Python often bails out after just one. The rest never even run. The guard pattern on a real calculation. Only work out the percentage if the total isn't 0. Total is 0, so the guard is false and the division is skipped. No divide by 0, just a clean answer, false. Anytime you divide by a value that might be 0, this guard is your seatbelt. Quick one. Does this crash? 3 parts joined by and. The first is true, the second is false, and the third is a division by 0. Trace it left to right and decide before we run. False? No crash. Python hit the false in the middle, knew thee, and was doomed and stopped, never reaching the 10 over 0. Get this one right, and you truly understand short-circuiting. One more everyday guard. Only look at the first letter if the name isn't empty. Name is blank, so the guard is false, and Python never tries to grab a first character that isn't there. False and safe. Reaching into an empty string would throw an error. The guard makes sure we never do. 2 real payoffs side by side. Short-circuiting buys you 2 things. Safety. A cheap guard can stop a risky check from ever running, so your code doesn't crash. And speed. Python skips work it doesn't need, so putting the fast, likely to decide condition first can save real effort. Order your conditions on purpose. Before you go, the entire Python 0 to Pro playlist is linked in the description. Every episode in order, start to finish. Go bookmark it and binge the rest. So, and stops the moment it hits a false, or stops the moment it hits a true. And Python never evaluates what it doesn't need. Order your conditions so a cheap, safe check guards the risky one. Try this. Set a variable count that might be 0 and safely print whether 100 divided by count is over 10, using and to guard it. 0 should not crash. You've been feeding conditions real true-false comparisons. But Python treats almost every value as true or false, all on its own. An empty string is false, a filled one is true. No comparison needed. That idea is called truthiness, and it's next.